Hello, good afternoon to all of you who listen to us from Europe. Good morning if you do it from the other side of the Atlantic. I am Philippe Lardy, CEO of Open Expo and collaborator in Beyond Innovation podcast. Today we received Victor Rodriguez and is software engineer on Intel. How are you, Victor?
Yes, I'm fine. Thank you.
Today, Victor has come to tell us about cutting-edge toolchain, the latest feature in GCC Glibc. And just remember you that you can ask questions directly through social networks or directly through our Telegram channel in the down part of the screen. So whenever you want, you can ask, and at the end of the webinar, I will ask the question to Victor directly. So thank you very much to be here today with us, and Victor, just go on.
Yeah, sorry thank you so much. Sorry for being a little bit late. So I would like to start this presentation with a simple question. Do you know that on a Linux system like Fedora, Ubuntu, SUSE, anyone that you have been using or you have heard about, only the kernel will have more lines of code than the GNU compiler collection project? In terms of lines of code, the Linux kernel is around 25 million lines of code. The GCC compiler, it's around 15 million lines of code. Okay, so it's a huge project, and sometimes it's hidden for many of us in terms of how does it behave, how does it grow the community. And this presentation will go to the latest feature that has been released in the couple of years, 2019, 2020. For us, that it's free to use, that it's free to use in our project, and why we need or encouraging you to move to the latest compiler collection. Sometimes it's a little bit challenge. Sometimes create a little bit of panic to move to the latest cutting edge technology because nobody has been using. But this presentation tried to remove those kind of problems or mistakes or afraid that you might have. So this is the history in terms of time from the beginning of the project born before Git. So this is a recompilation that we tried to do in the GNU project. I'm part of the GNU project since 3 years ago. Through the history of how much lines of code has been growing, the project, just for the compiler. Important. This is not considering other parts of the GNU collection. So in software, a toolchain, and you might wonder why they label these as a toolchain. Well, a toolchain is a set of programming tools that is used to perform a complex software development task or to create a software product. So these toolchains that we have over here for us that are free to use, free to modify, free to make releases and include in our project are the set of elements that will be useful as the tools that we see in this picture to create our projects, right? For sure, the GCC compiler has been one of the most used, but there are other components that are over there hiding that are useful for us on every day. For example, what set of tools do we have in the toolchain collection? The debugger, GDB or LLDB, very useful, very powerful if we know how to use it. It help us to figure it out. We have segmentation faults, null pointers, piece of pointers that are creating a lot of issues. Linker. So when we create a code, even for example, when we print a hello world in our C code, we don't use, the printf was not created by ourselves. We just put in main, include stdio.h, and then inside of main we put the printf and say, hey, hello world, this is Victor. But no one else create the printf. Somebody has to create that library. How do you link that library on runtime when it's being executed and on loading time when it's being loaded into the memory from the scheduler, and the memory management make the arrangement to make that process run inside your operating system? Well, the linker is the magic wizard that make that job for you. Usually known as LL or LDD in user leaf or user bin. The assembly or disassembly, the GNU gas or assembly generator is the one in charge to generate the assembly thing that is going to be able to be executed into your CPU. binary utils or Bing utils. Well, that is very common thing that you use, and it's the Bing utils thing means how do you use ls mkdir to create a directory, to list directory, to cat to open a file. Many of the still things that you use every day are created by the binary utils or Bing utils, and that is part of the Toolchain project. Emulation library, the GCC. That's an interesting thing. So most of the CPUs, as we know, have been evolving since the last 40, 30 years. However, those things are not always, has not always been as smart as we think. There will times where the division or specific instructions were not part of the instruction set of the microcontroller or of the microprocessor. And libgcc was the library in charge of emulate that part of complex instructions inside for the user. Standard C library or glibc, it's the library that actually make us handle things like open a file. When we are doing a C application, we say, hey, I want to open a file, or I want to close a file. I want to read from that file, write into that file. I want to change all the system calls that we usually interact with the kernel and say, hey, kernel, please do this system call for me. I'll handle it mostly by glibc. Other things, and we will see in this presentation, like how do I calculate sine, cosine, tangent, all the mathematical functions that are intrinsic for me, that it's just include math.h, are in glibc. And those are created every two times per year by the glibc project. Now, these are the set of tools that we have over here for everyone, right? This is the set of tools that we produce for the GNU project to the world. We release this thing every year. In some cases, like the standard C library or glibc, the cadence of release is 2 times per year. So that is very important to notice. Every year you will have fresh and new tools with new enhancement. Now, what have been built with these tools? Um, Many things. So operating system kernel. The Linux kernel is built today with the GCC compiler. There are some good efforts, and I'm very happy about that, to move to Clang or LLVM compiler from Google. And that is important. That is amazing. Greg Harman, Linux kernel maintainer today, mentioned something very interesting a year ago when there was a huge boost in the improvement for LLVM compiler to be able to use as a kernel main compiler, and say that's fine because now GCC compiler has somebody else to compete with, and to compete with somebody else in the open source, it's very interesting because it forces us to create more and more and more things, right? However, today, as 2020 May, the operating system kernel is compiled only by GCC today. Image, or the latest version, of course. Image processing libraries, OpenCV. We have heard conference or videos or blogs about how powerful is OpenCV, especially now for machine learning that interact with things like TensorFlow or PyTorch or many other stuff in libraries for machine learning, but they base the core in things like OpenCV. Well, OpenCV is compiled with GCC. Websites, scripting languages. You know that PHP it's in C. So when you want to build a new version of PHP, for many of us, it's very transparent. In case of Ubuntu, sudo apt-get install PHP, and that's pretty much what we need to do. Or doom install PHP, but somebody has to build it for us. Somebody has to provide us packages for us. And if we want to use the latest version of PHP with some security feature or something important, we need to compile by ourselves. Now, PHP, Python, for example, it's writing in some kind of weird thing that it's compiled in C Python. However, it's compiled with GCC. Okay, so all these projects around the world has been very widely used by us, and they are being used in the GNU compiler collection and other tool chains. Now, let's go into the first section of this presentation. How does the latest technology in compilers help security? Well, the first that I want to present you is FCF protection. There are many kinds of security attacks, many kinds, and the industry has been showing us during the last 2-3 years amazing examples of how to exploit security through internet, very wide. So, but I'm going to talk to you about two cases in this one. return-oriented programming and call jump-oriented programming. Very common, by the way. Reading an article few days ago, it was mentioned that this kind of attack, due to the simplicity of execution, is one of the most widely created or most widely exploited around the internet. How does it work, the return-oriented programming and call jump-oriented programming attack? Well, the good thing is that GCC 8 helps to prevent them. And in case that you might wonder, what is the latest version of GCC? I'm very happy to share with you that the 1st of May, 2nd of May, was released the first release candidate, and last week was released the GCC 10. So this technology has been here for 2 years, and many of the projects that we see on the open source are taking into consideration this one. Now let's go into the return-oriented programming attack. What do we see here? Well, in this case, we have, as you can see, very simple thing. We have a main, and that main, it's going to call the function echo. Echo is going to say, hey, enter some text, and we're going to scan a buffer that the user can type, hi, my name is Victor, or hi, open source community, hi, conference, I'm here, and it will return the buffer that you read. However, we are using some very old and not very efficient way to read from the user, which is a scan. On the top of the code, you will see that there is something called secret function. And secret function is never, ever, ever reached by any point. As you can see, in the main, we call the function echo, but we never call the function secret function. And inside echo, we never, ever call the secret function. So it's not possible by any logic inside the code to reach secret function. Secret function is going to have something called print, congratulations, you have entered in the secret function, because it's not supposed to be entering to that function. So let's imagine that simple code. The security hole is in scanf, but you might wonder how? Well, by something called buffer overflow. And it's very simple to create. How simple? I can teach you in this presentation how to do it. So the first thing that you need to do is, of course, create a buffer so long that will override all the thing into the memory heap that will allow you to put in a specific position the address of the function where you want to jump. And what do we do? Well, in this picture you see Python -c print 32 times the char A. You can change the char to B, C, D, any specific char that you want to bring, doesn't matter, it's just garbage. And then we put the address, right? We put the address. You need to figure out if it's little endian or big endian according to the architecture that you want to attack. And then you pass that buffer, because it's going to print a huge string, as an input to my binary that I have just compiled from the previous code that I show you. And that's the surprise. When you enter the text, you will see over here the 32 times A, and then the address that you want to pass into the buffer. So when you override that buffer that we saw in the previous example of the code, you will override the heap of the memory, so the stack of the memory, and put into the specific position where the return address from main. Why? Because echo was supposed to return to main. But when we override the address, instead of returning to main, it's going to return to secret function. And as you can see over here, it said, congratulations, you have entered this secret function, segmentation fault core dampened. Yeah, it creates a segmentation fault. Nevertheless, it goes into the function that we wanted to go. Now, that's funny, because we have just entered to a secret function, and as you can imagine, nobody should be labeling a function secret function. The secret here is to do the math of how much chars, in this case, how many A's you have to put into the buffer in order to put in the specific position the address that you want to jump. If you just put garbage and not the address of where you want to jump, it's just going to give you segmentation fault, core dump it. That's it. But you will never jump into the function that you want. However, that is interesting, because if we jump to a gadget or a piece of code that we have created, that is also possible. Inside the stack, I can put into the return the address that I want to return any place. Okay? For example, if I create instead of putting the red, I make this instruction, move EAX. Then what I'm doing here, it's moving to AX from Intel perspective of assembly, the value 10 into the register. That is a forbidden instruction. I am malforming the instruction that I want to put inside a register, and that is an instruction to the CPU that the user was not supposed to do. User never asked for that to happen. However, me as a malicious code making it work without even modifying the source code of the application. And there are other shellcode database for study cases that I put over here. And the good thing is, it's just there are people doing PhD or master degrees about this topic. It's instead of putting that assembly basic instruction, you can jump to a binary that it's loaded into stack that actually has the hexadecimal code for being bash. And the good thing is that now you're going to be jumping to a bash command line with root permissions, because the execution was inside at kernel level space with super user permission. So you will be root by doing this arrow p attack. Now, how you might say, well, this is very terrible. How can I help my application to fix this? Well, just introduce any options, and that option is fc-protection with multiple option, full, branch, return, and known. The new fc-protection option enables support for the control flow enforcement technology, or set technology, that is going to be enabled in Intel CPU that is coming this year. How does it work? Okay, the FC protection checks the valid target address of the control flow, and then check if there is an indirect jump. This prevents diverging the flow of the control to an expecting target. Let's say, and I like this picture, in the right side, we have the program counter that is executing the instruction that we want. Read, in this case, was the analog for scanf. And in the left side, we have the instruction pointer. And the instruction pointer, it's writing hello world. And 8004 is the address where I'm supposed to jump. When I override by the buffer overflow or a return-oriented programming attack to the address 8001, as we can see in the picture, it's going to jump to another part, in this case, the function that I want to execute, that could be bash, or it could be something that overflow the memory, anything that is malicious. But that is a diverge in the control flow. So the FC protection detect that kind of jumps or diverge in the flow, and terminate the program, cancel the execution, clean the stack, and come back to the next process. Prevent from any manner or any possible way that the hacker could actually jump to the function that you want. How does it work? Okay, you can compile your code with FC protection full, branch, return, unknown. So what we are going to happen is the value full, it's analyzed for specifying both branch and return. If we specify branch, it tells the compiler to implement checking of validity of control flow transfer at the point of indirect branch instruction. As we know, when we are executing a code into the pipeline of the CPU, there are branches of execution. Now, that branch of execution is when we jump to another function, when we jump to another piece of memory, anything that we want. But when we do that jump, it's a branch diverge. And that branch diverge is going to be checking, in this case, but FC protections, hey, just check the branch jumps that I have. If there is a branch call or a branch jump, check it and check if it diverged from what I was expecting. If we set return, it's not going to check the branch diversion. It's going to check the return pointing when I came back from the function. So it's going to allow you to maybe execute, but when you return from that function, if the return it's to some other pieces that it's out of my heap, it's not possible to execute. And the value full is going to check both cases. Is there a penalty in performance? Yes. Security always going to have a penalty in performance, or most of the time has a penalty in performance. I don't have the numbers of how much, but yeah, it creates an extra layer in terms of execution for your code. The value nonce just turn off this execution. Now, control flow enforced technology, or set, provides the following capability to defense in these cases against this. It will enable two things, and this is now at the level of the CPU. Remember, compilers and CPU are very tight. Most of the time, compiler designs are very close to new instruction designers, because how we're going to be using this new instruction or these new capabilities need to be known at the first hand by the compiler designers. Now, shadow stack. Shadow stack is the first thing that is going to come up with the new CPU. This time it's going to be Tiger Lake, I think so. The idea of there is a second task that is used only by the call return instruction and interrupt processing. So we create another stack. If the stack is what is supposed to be override, we're going to create a copy of that stack, just saving, right? When the call instruction is executed, the return address is writing in both stacks. So it's like to having a copy. Imagine that your friend said, "Oh, I'm gonna go to the laundry." You save a copy of the state of your friend, and when or a picture of your friend, and when it came back, if it changed the clothes. So in this case, we have the stack one. It makes the call. The return address from the stack two. If they diverge, it's gonna crash at this point, right? Now, that's regarding to security. The next optimization that we can see in the latest compilers, it's about performance. F-loop interchange. This is very interesting because that require to have no optimization for sure. The OS means I want you to make the smallest possible binary size as you can. How does could that happen? Well, minus OS, it's going to make all the performance optimization, not in terms of improvement of memory transactions or speed in time for CPU execution. No, no, no. It's going to make the binary as small as possible. For why that is important? Well, we know that there are many applications around the world with the size of the binary matters, and we don't have that many memory, right? And there will be other cases in where the amount of the size of the binary matters, and we don't have that amount of memory or hard drive. Um, so, but the other optimization, O1, O2, and O3 are like an onion, like the levels of the onion. We have O1 with the first basic optimization, O2 with more optimization, O3 with even more optimization that are nested the O1 and O2. Well, in this case, F-loop interchange is one of those optimizations that are included in the minus O3 optimization. So if you compile with minus O3, which is the highest level of optimization, for the GCC compiler, it will be included, right? So let's take a basic example how we can do the performance F-loop interchange. Well, we have a very basic and simple code, right? We have an array of integers. The size of the array is 1000, 100, and we're gonna have two loops, right? Because it's a b-dimensional array. We go from 0 to 100 first with the variable y, and then we use the variable x to go from 0 to 1000 for the variable x. And now we're gonna do later that the position uh, of the x comma y, it's going to be in that position we're going to store the multiplication of the same values of the iteration that we have, x times y. Very simple. It's just for didactic purpose. This is not part of any application, just for didactic purpose for this presentation. Now, from the first slide that we see in this code, it should be right. Okay, I mean, from the functional perspective, if that's what we want, I don't see any more performance optimization that I can change in my code. Nothing at all. Well, what we want in software is something like this. We want in software to go from y from 0 to 100 and x from 0 to 1000. And we want that will be storing in k 0, 0, 1, 1, 2, 0, 1, 0, 2, 0, 3, 0, right? What hardware needs to do, and that's something interesting. When we code, we don't care much our friend hardware because we assume that it's your own problem. No, in reality, the problem the hardware suffers sometimes. What hardware needs to do in this case is we have the CPU, we have the cache, and then we have the main memory, right? And just assume cache, not think about L1, L2. No, no, just cache. Let's do it to the basic. And cache one, it's going to be storing things like K0, K01, K02, K03, right? On this level of the of the code. Okay, so and that goes from 0 comma 999. On the cache line 2, it's going to be stored k1 comma 0, k1 comma 1, and so on, and the cache level k2 comma 0, and so on. Well, the problem here is that since we are asking, as you can see on the left side, k00102030, it's gonna read that it's stored in the first part of my line of cache. So I have to go and read the full line of cache 1 just to read one value, and then discard the entire row. Move to the next one, read k1 comma 0, and discard all the other part. K3 and discard it. So I make calls to the cache very often just to read one value instead of reading the full line. How do I fix that? Before that, memory facts. When a process accesses to an array of elements the first time, it retrieves an entire cache line of data from the main memory to cache memory. We know that principle for the facts of memory. If the rest of the data will not be used soon, this is a major if this used very soon, it's a performance boost. On the other hand, if the rest of the data is not used, it's a performance loss. Okay. When an f-loop interchange flag is used in our compilation, where we compile like GCC f-loop of optimization, f-loop interchange flag, it's changed the order. Instead of having x in the inner level of the loop to the outer level of the loop. So we interchange the loops, and the memory controller is optimized for memory location. Now we read k0, comma 0, and k1, comma 0, comma 1, 0, comma 2, 0, comma 3, 0, comma 999. That is the full line that is being read, and that is going to be a better use of the memory because we have used all the line of cache for that moment. We can discard that, read the second line cache 2, and that will go on, and then cache 3, and then cache 4, and we have been using all the cache that we have retrieved from memory at all, and we haven't wasted anything at all, right? So that is very interesting because just by switching or by interchanging the loops, that is going to make the huge difference in terms of performance optimization. So instead of going for a full line of cache and just using one value and then just throw it to the garbage, and then going again for another line of cache and throw it to the garbage, no. We go for the full line, we read the full line, we use it, and then we throw it to the garbage, but we have used it all, right? Um, I don't know. Is the speed of the presentation okay? I just want to make a check.
Yes, it's correct.
Okay.
Perfect.
Okay.
You can go on.
Thank you. Yeah, sorry, I just needed to check. Code hoisting optimization. This is very funny. It's one of the most sweet optimization that you could have in some way. Why? Because it refers to partial redundancy elimination, PRE. Eliminates unnecessary redundant expression of some paths through the code. On the left side, I put you a redundant definition of some code. You can see that I have a function test that receive A, B, C, and G. D is not received. That's interesting. And D, comma E are defined inside the function. If A, it means if I have any value that it's different from 0, I go and set D equal B times C, else I do D equal B minus C, E equal B times C plus G. Return D plus C. So the thing that matters here is at the end, I'm going to return what D plus E means. So if I know, and this is interesting, that I'm passing as a function to the function 1, 2, 3, 4, I'm not passing a variable that is going to vary or be modified over time. I'm passing a constant. So the compiler could detect this thing and say, wait a minute, A, it's always going to be 1. So I will never, ever go into the else because A always is going to be 1. Why? Because once you compile this code, the binary, it's not going to be possible to be modified. This is not like a variable that you can pass through f to scan, or give me the value of a, please user. No, no, no. This is a value that always remain for the history of the history forever, because I already compiled the code and it's not possible to modify unless you recompile, but that's a different story. So the else will never be executed, only the first one. So I know that d is going to be b times c, and e is not going to be of any value. So why do I have to perform the execution if d plus c, e is the other part that it's missing, and e is not defined because a is always 1? Why do I have to execute d equal I just need to execute that line, d equal b times c, and I don't need to care about more. So I need to forget about doing the if else. I need to go straight forward, assign d equal b times c, plus e will always be 0 because was never defined before, and that's the only thing that I need to return. That is created with the F code hoisting. F code hoisting lives in the -02 optimization level or higher. And also, this is important, in -OS. So for those of you that are here in the webinar that are interested to reduce the size of the code, well, use this one because it will remove part of the assembly that you generate, and use the -OS and be sure that your compiler has F code of hoisting included. Code hoisting tries to move the evaluation of expression executed at all parts of the function and then exit as early as possible. Code hoisting, it's like, okay, I'm going to remove everything that I don't need. I'm going to be focused on what I do care. And this is a difference between object DOMs, or in the assembly between the example that we saw before with -01 and -02 with the F code hoisting optimization. As you can see, it's different. It returns the minimal thing. It's reducing in size and doesn't do the many of the comparisons that we had before, right? It doesn't have, as you can see, the jump equal at the line 1131 on the left side. It doesn't do the jump equal because it's not doing the comparison at all. Okay. This is another example of code hoisting. We have a function for void f, integer x, y, int y, I, sorry. And as you can see, inside the for, we do a equal a in the index. It's going to be equal to x plus y, but that is never being affected by the index, right? So we can create, as you can see in the second block on the right side, equal to x plus y, and that is going to be the value that always going to be assigned to the a index value. Because I execute that instruction once, I save the value, and it's going to be stored all the time, which is much more simple and easier. I'm going to be go straightforward in this one. Well, glibc. Now let's take out from the compiler and move to the linker for the math optimization. Well, the optimization that we had in the latest glibc 2.25, I think so. It's this one, and one of these core algorithms for the function that was improved was the s-sin-cos.c file. Now it's calculated by polynomial way. So instead of using very expensive float operation, we use integer operation with polynomial. It's less precise, yes. It's that close to precision, no. But it goes extremely faster, right? There are some advantages of using the polynomial method for calculating sine and cosine. First, the memory requirements necessary to implement such polynomial are quite small, so we don't need to use that much memory. We use less memory. Polynomials only requires multiplication, addition, and subtraction of floating points number, which normally take very few CPU cycles. Before, there was very complicated instruction to calculate the sine, cosine, and of the angle that you want to calculate. I put you here the link to this sinecos where is the new implementation. And the last one that I want to show you is developer experience. So there has been a lot of things that was implemented in the latest years about developer experience, and you will maybe this is the most tangible way that you could see the latest change to the compiler. So let's take into consideration this one. Int main, and then we have color, we have print hello world, and then we commit a mistake. a very basic, simple mistake that we commit all the day, all the time, a typo mistake. So instead of printing color, we print color, adding a U, and then we say return zero. And well, that is a mistake. It shouldn't compile. No, it does not compile. But not only this, it tells us the compiler, hey, I think that what you wanted to set was color, not color, not color. So it prints you the change and the fix that you have to do in the specific line. And it's like a new friend that tells you, hey, dear developer, please fix this. You're committing a mistake. Diagnostic generate patch. If you don't want, if it's a huge code, like thousands of lines, and you say, okay, I have a lot of mistakes. Oh, I have to go line by line and no, you can set fdiagnostic generate.patch and generate the patch for you. For those that are used to use Git, you can apply, it generate the patch for you. You can save that into a file.patch and apply that patch on top of your Git repository, and it will have all the fixes for you. So fdiagnostic format, it also can generate things in text or JSON if you want to feed maybe a web page or something that want to show you the report in your CI/CD. The next example takes a previous code and print the things in JSON format for you. Yeah. And the F3 switch conversion, for example, if you have this switch over here and you have case 2, or if I pass as an integer how it's going to be equal to 205. If it's 3, it's going to be 305. If it's 4, 405, and so on until 6, so 605. As you can see, we can see as a human, there is a pattern. So it takes 100, multiplies by how, and add 5. Well, compilers now take that into consideration and generate on the right side and left side. You can see the huge thing with what that was created from the previous code without using the flag F3 switch conversion. And now with this new flag, we reduce that to voila, doing that addition and multiplication. As you can see, the reduction in size, it's quite considerable because the compiler find the pattern of what you wanted to do and reduce the size to the minimum, and also improve the performance quite a lot. And there is other things that came up in the latest compiler, like fno diagnostic show line numbers, w or warning for allocation larger than. So you can put w alloca larger than 200 or 2024 or any size that you want, and it's gonna warning you if you're doing an allocation in malloc or any other version of malloc larger than what you suppose. So it's good for you as an architect, because you want to check before releasing if your application is storing more than X amount of data. Yeah, you can use it, f alloc larger than, and it will show you the warning where it has. It has a new access to get CPU system call. So from the user space, you can see in what CPU you are, in what node of the machine you are. You might say, why is that important? Well, when you're using HPC system, it's important to know in which CPU you are and how many CPUs you're using. Right? So as a kind of summary or warm-up, this is a phrase, very interesting. The open source community behind the development of the GNU Toolchains project use the innovation to propel the core of the technology we use every day. There was a sentence that I used that I heard in a conference last year in San Diego, before going into, or when we were doing the coffee break, and that is very interesting. It was very touching for me because it's reality. We in the GNU community, I'm proud to be part of that since a few years ago, try to give part of our time to create new technology for everyone. That these kind of new things that I presented to you today could be useful for your project. Even if it's a small project or a huge corporate project, doesn't matter. It's where our idea is that to give you the best technology so that you can produce the better binaries, the better libraries for your application and your end users. We have some examples I put you here about this one. There are some papers that I have or blogs that I have written about this thing from GCC 7, 8, and 9. You can see these online. You can go and visit each one of those. And that's it. And this is it. Thank you so much for your time. Any question? Yeah.
Yes, there is one question from Mario, and it's about the roadmap. In the in the GCC glib C, what's next in the roadmap of in the roadmap. Yes.
Yeah. So every single project has their own roadmap. For example, GCC 10 came up last week with new features, and there is a pre-planning phase on that we gather into a meeting by IRC or by mail, that where we put the roadmap of what is going to happen. Usually things that didn't make it into GCC 10 go into GCC 11, for example. And also, if somebody from the community said, hey, I want to put in this thing because it's a new feature that I want to enable, they are free to go, and we are more than happy to take it. As an example, RISC-V, a very hot new architecture that it's open source architecture, and it's making a lot of sound in the technology community, came up to us and say, hey, I need your help. I want to do it. I just need the training to enable RISC-V into GCC and glibc. Could you please help me? And we say, yeah, sure. By the way, you also need to enable that on the kernel. So it was a cross-team collaboration. There is not a specific roadmap, but we can join. You can join to the mailing list and ask for the list of topics that are in the incoming release.
Okay, I was just checking if there was another question, but there is no more question. Just let me check a second.
Let me turn on the video. Maybe I can. I didn't know that I had not turned on the video. Give me 1 minute.
Yeah, just don't worry.
Can you see me?
Yes, I
Great.
can see you.
Perfect.
So if you have any question, you can do it directly through the link on the down part of the stream. It's on our group Open Expo Europe on Telegram, and you can ask directly through social networks or through the chat of YouTube if you have any more questions. If you want to
Okay.
add something,
No,
sure.
thank you so much for the opportunity for the Open Area Expo to be here. More than happy to present. It was very interesting. I hope that any question that you could have, send me to the proper channels or to me. You can find my mail on the social media, and yeah, I will be more than happy to ask any question.
Okay, if you can put your direction or your email address
Sure.
just on the screen, if people
Yep.
so people can see this information.
This is the mail that I use for all the open source community. Let me go to full screen. Yeah, you can send me mail to that one. I will be more than happy to ask. This is the mail that I use for the GCC compiler for glibc, and all my patches for the community are signed with this one. So yeah, you'll find all my contribution with this mail.
Okay, and there is a question from Josue. Josue,
Hmm.
sorry.
Yeah.
Can these security features change the behavior of my code?
Can these security features? Sorry, what?
Yeah, I repeat. Can these security features change the behavior of my code?
In the terms of set, no. It doesn't change the behavior of the code because it doesn't change or modify the instruction inside the flow that we have for the application or for the code. The set in the case of the shadow stack is gonna go and say, okay, I'm gonna create a shadow stack, and every time that you do a jump, branch, or call, I'm gonna compare if you're coming from the right or you're coming to the right function. If there is a misplacement or a different address, it will just crash. It will crash application, yes, sorry for that, but it will not modify the behavior of your code. In the terms of the return address, it's going to have a new register, and the return address is going to match and check, oh, the return address match with the previous one that I said before. And if it's the case, it's going to come back to the address that you want. And if it's not the case, if it just again crash the code. By the way, this new instruction and shadow stack, if you compile your binary for set and you're using a platform that does not have the new instruction, the opcode that or the instruction that are generated, it's equal to NOP, or not operation. So there is no issue if you compile for set and you execute in a platform that does not have the latest feature for these CPUs, it will be considered as not operation. So you will not have the security, but you will not crash the code because you're not in the latest platform. But to answer specifically the question, it does not change the behavior of the code, the set.
Okay, we're checking for the moment. No more question. You have a couple of minutes if you want to ask some more question to Victor about GCC and glibc. And if you want to add something, Victor, or if you want to go on with some information about what you're doing in Intel with all these kind of things.
Um, well, I'm software developer engineer at Intel. At the moment I work in the Stacks, Intel Stacks project, helping the team with um, performance optimization, some parts of compilation issues that might come up. I don't know, many different kinds of activities on my daily basics, but mostly I'm there because of performance optimization or looking for performance gaps into the Intel stacks.
Okay, if you have any question after this webinar, you can do it directly through email to vm.rod25@gmail.com. And thank you very much, Victor,
No,
to
thank to
have
you.
been here with us today, this afternoon for Europe, this morning from the US and South America and well, Latin America. And thank you very much to those of you who have followed us today. And if you like this content, do not hesitate to share it, like it, or subscribe directly to our YouTube channel. Thank you very much.
Thank you. Have a great day.